Well, very good afternoon to everyone.
Good afternoon, sir.
Sir.
In the last class, we had discussed about an introductory session of data structures. So, what actually the data structure is. So, what are the different types of data structures generally we have? So, what is a linear data structures? What is non-linear data structures? Uh, Then under linear data structures, we discuss about the stacks, queues, and the linked lists. And nonlinear structure data structures, we have categories like the trees and graphs. So today we will more in detail. We will discuss about the other data means one by one the data structures in details, and we will uh, see their implementation also from the today's class. So today, first data structure which I would like to discuss is about stack. What is stack? What data structure? How it is going to work out, and how it is being implemented? We will discuss. The stack is actually a linear data structure in which the elements are inserted and deleted from the same end. So where the elements are put from one end and also removed from the same end, it is a stack data structure. It is an arrangement. So in this, the insertion generally called as push operation, and the deletion is called as pop operation. And stack follows the principle last in first out. It follows the principle last in first out. As I told you in the previous class that, so if suppose some fruit plates are there, so what we are going to do here is we are going to put one plate on another. And when we are supposed to remove, we will remove the topmost plate, means the one which you have placed last will be removed first. Likewise, see the chair, stack of chairs also we can call. So one chair is placed on another chair, but when we are removing, the one which is placed last will be removed first. So this principle is actually followed by the stack. So the stack can be implemented in two ways. So it can be implemented using an array, and we have the dynamic implementation using pointers also. So today's class, we will just discuss about the array implementation of the stack. So when we discuss about the linked list, then again we will come back and we will see how a stack can be implemented using the linked list also, the dynamic implementation. But today we will just talk about the static implementation, or we can say the implementation of stack using arrays. Okay, so now what type of operations which are performed on the stack? So you can create a, first of all, a new stack can be created when we have an empty stack where no elements are being placed there. Then we can have an push operation where an item, whatever the item, whatever the type of content which you want to store in the on the stack, can be implemented by this push operation. Then we have a pop operation where the element can be popped out when the topmost element will be removed from the stack. Okay, the topmost element will be removed from the stack. And we have an peak operation where actually it is going to return the topmost element. It is not going to remove the element from the stack, but in fact it is going to just show you what is a topmost element. Then we have is empty. Is empty. What is this is empty? So it will test whether the stack is empty or not. So if the stack is empty, then it is going to return that the value. It is going to return true. Then we have size, which returns the number of items of the stack. So these are such types of operations which you can perform. So again, these are not mandatory that you need to implement all these functions. So it is up to the programmer. So what type of operations which he is supposed to, what type of functions he is supposed to implement. But you must be sure that you must implement the push operation, the push function and the pop function is mandatory, because to insert an element you have a push operation, that to remove an element you have a pop operation. So now see here the stack condition. So these are the two conditions of the stack. One condition, the stack is empty, the other condition is stack full. So if suppose the size of the stack is 5, So all the elements have been inserted. So when the top is null, when the top value is null, if the top value is 0 or the top value is null, you can say that the stack is empty there. Then once we start inserting the elements in the stack one by one, like the 5 is first inserted, then the 8 is inserted, then -7 is inserted, then again the 8 is inserted and 9 is inserted. Once the top value comes to the topmost value in the array, then we can say that stack is overflow, because you cannot insert more number of elements in this stack here. So that's what. Next is, see this push operation. The process of adding one element or an item to the stack is represented by this push operation. So in this figurative means, in this figure, if you observe that the first figure, the stack is empty. We have an empty stack. Then when you are inserting an element A, the A is inserted, so it is the topmost element. Then again B is inserted, then B is inserted above A. So B becomes the topmost element. Then C is inserted above B. Likewise, the remaining elements will be inserted until the array is full. Once the stack is full, now it cannot doesn't have enough space to actually insert an element, then you can say that the stack is full there. Then you have a push operation here. The process of adding one element or an item into a stack is represented by an operation called push. So adding an element or inserting an element into a stack is called as a push operation. So this is an algorithm which is given here. See, generally in the examination, remember that you should, if suppose if the direct program is not asked, then you're supposed to write the algorithm. Okay, you're supposed to write the algorithm. So a data structure, because as I told you in the previous class, that data structure is not anything specific to a language. It is an independent subject where the implementation can be done in any language, the chosen language, whether it can be a C language or C++ or Java or whatever the other language here. Now, for suppose say here this algorithm, what this algorithm states, we will see. So stack is an array with an element. So I suppose a stack is an array of an element. So top is a pointer that pointer to the topmost element of the array item is to be inserted. So now you have this particular operations here. So push operation, we have a stack, we have a top variable, we have the size of the stack, then the item which is supposed to be inserted. Okay, now it is checking. See, what is the first step? If top is equals to n, if top is equals to n, if suppose the n elements are supposed to be inserted into a stack, if the top value is equals to n, so then you can simply say stack is full or stack is overflow, then you need to exit, because you don't have any space to insert into the stack. If it is not, then you should increment top by 1, top is equals to top plus 1, then stack of top is equals to item, item is inserted, then you are going to return. So all these things you will be seeing very soon in the program. I will explain you the C program which actually implements the stack. Okay, there you can have a clear idea about this. So this is of course algorithm also you should have an idea. I hope you got an idea. So if suppose top is equals to n, if suppose n number of elements in this array, if top is n, top is n, you can say the stack is full and you can exit, because you don't have any space. Otherwise, you should increment the top and then you need to insert the element. Okay, then the next thing here is the pop operation. Pop is nothing but removing an element here. So it is a process of deleting or removing an element from a stack here. So because it follows the last in first out principle. So previously, as I told you that now here first A is inserted, then B, then C. Now when you are removing, first the C is removed first, then then B, and then A. So first the C is removed when you say pop, then you say again pop operation, B is removed, then again pop, A is removed, and then the stack becomes empty. Okay. Next, the algorithm for this is the same thing, where you can say stack is an array with n elements, top is a pointer. Now if top is equals to 0, if top points to 0, then you can say stack is underflow. Okay, stack is underflow, or stack is empty. Otherwise, item. So what item you want to remove? You're just assigning it to an item, stack of top, Okay, copy the item into the top element, then top is equals to top minus 6. So you are decrementing the top. That's what you are going to do. Okay. Peak operation, of course, the process of returning the top item from the stack, but does not remove it. It is not going to remove it. So again, if top is null, then you can say that the stack is empty. Otherwise, simply return stack of top. Just return that element. You are not going to remove the element. Removing means you are decrementing the top value. Here, you are not decrementing the top value. You are just returning the topmost element here. Okay. Then we will talk about this applications of stack later on. But now we will discuss the program. So here is a program where I just designed it. Just designed it to implement a stack operation. Now, for suppose, uh, see, these are all the global variables which I have discussed. Global variables which I have declared here. Int star stack. So a pointer called stack. Pointer called stack is declared. Then we have top, which is assigned to -1. Then you have the size. Then you have the prototypes of the functions which I'm going to implement in my program: the push function, pop function, and show function. Okay. Then you have the main, which is started. Let us see what the main is doing. So first is enter the size of the stack. I just want to create an array dynamically and not taking array of fixed size here. So first the users wish what is with the size of the array. Now, for suppose the size is entered, means in the variable size it is entered as 5. Okay, 5. The size is entered as 5 in the scanner statement. Then a stack is created int star malloc of size into size of integers, means 5 into size of integers, means an array of 5 elements is created. An array of 5 elements is created. Right? So we have the 0 element, 1 element, 2 element, 3 element, and 4. So right now the stack is empty. Right now the stack is empty. Then while 1, the meaning of while 1 is while true. While true means this is an infinite loop which continues. It continues. Okay, so while 1, it is going to display a menu: push, pop, show, and quit. 4 options: 1, 2, 3, and 0. So if 1 is entered, so it is going to push an element. If 2 is entered, it is going to pop an element. 3, it will show all the elements in an array. If you enter 0, it is going to quit. Okay, just I will do one thing. I will just show you the working of this. Then I will explain you the code. I hope it will be better for us, more interesting. Yeah, control F9. I'm pressing. Enter the size of the stack. So I entered it first. No problem. Size of the stack, entered it as 5. Then see, the menu is displayed. Now it is asking us for a choice. So what is your choice? 1, 2, 3, 4. Now see here, I am trying to giving directly 2. Right now stack doesn't contain any elements, so I'm giving it 2. Then it is saying stack is empty. So if you observe that stack is empty. So even if I try to show the elements also, it will say stack is empty. Now if I say 1, I want to push. Now it is asking what number you want to insert. Okay, 10. Is the screen visible to you, everyone?
Yes, sir.
Okay, okay.
Yes, sir.
Okay, thank you. So enter a number. So I entered 10. So 10 is inserted actually. Again I say 1. This time I entered 20. So 20 is also inserted. So this time 3. Let us see. So it is displaying 20, 10. See, topmost element is displayed first, 20 and 10. Again I say 1. And this time 30 is inserted. Again 1. 40 is inserted. Again 1. 50 is inserted. Now the size of the stack is 5. I inserted 5 elements. Again I will try to insert an element 1. So then it says stack is full. So if you observe the output there, it is saying stack is full. Now if I pop means the last number which is inserted is 50. So 2 is in, if I give 2, see pop number is 50. Now if I observe 3, only 40, 30, 20 and 10. 10 which is inserted first is displayed last here. Okay, again if I try 1. So what number I want to insert? I want to insert 25. Okay, 25 is inserted. Now if I show 25, 40. So now I just want to pop the elements 2. Okay, number popped is 25. Again 40 is popped. Next 30 is popped. 20, 10. Now again I'm trying to pop. Now it is empty. Now if I give 0, it's going to quit the program. So this is what is the working of the program. Now let us go back to the code and discuss what it is doing. Now this is what is a menu. While 1 means continuously until I give 0, it is going to continue with the loop. It is going to display this menu and it is asking us for the choice. As per the choice, because I'm using switch case here, I'm going using switch case here. If the case is 1, it is going to call the push function. If it is case 2, it is going to call the pop function. And if it is case 3, it is going to call the show function. And if it is case 0, it is calling the exit 0 function. You know the usage of exit 0, it is going to quit from the program. Now we have the default, if suppose other than this 1, 2, 3 and 0, it's about if any other value is given, so it will display it as invalid choice. Right. Now, what actually happens at the push function? Now for suppose, as I just said, here it is. So I gave size as 5. Now, if you observe, top is actually by default it is assigned globally. It is assigned to -1. Top is assigned to -1. So we will take that value also now. This is because those are the global values. So for suppose the user has entered the choice number 1. Top is equals to okay. I will just assign it. Top is equals to -1. Okay. Top is equals to -1. If top is equals to size -1, what is top? Top is -1. 9 - 1 is equals to size -1. 5 - 1, 4. Top is equals to -1 equal to 4 is false. Then it is going to come here, enter an element to be inserted. So for suppose you entered n as 10. Suppose n is entered as 10. Then stack of ++ top. So pre-increment. So I'm using pre-increment here. First the top is incremented, then it is assigned to that particular place. So stack of ++ top. So top will -1 + 1 will become 0. -1 + 1 will become 0. Okay. So -1 + 1, top will become 0, and the 10 will be inserted at this place. 10 will be inserted at this place. Then again, for suppose again you are calling uh, uh, one function, so again it will come back again. Suppose you have entered the choice one, again it will come to the push function. Then top is equals to size minus 1. Top is how much? 0. 0 is equals to 5 minus 1 is 4. 0 is equals to 4 is false. Then it will come back here. I'm asking for a new element. Now element is suppose 15. Again, stack of plus plus top. So top will become 1. And then that 15 will be inserted here at the position 1. Got it? Again, if you enter a 1, again if you are entering 1, again it will come back here. So just for convenience, I will make it 3. I hope you will are following. I'll make it 3. Now top enter element. So this time again top is equals to size minus 1. Top is how much? 1. 1 is equals to size minus 1. 1 is equals to 2 is false. Again it will come back here in certain element number. This time if you have entered 20, for suppose 20 is entered, then stack of plus plus top. Top becomes 2. Top becomes 2 and 20 will be inserted at the third position in the array. Right. So now if suppose fourth time again if you want to push the element, if you're trying to push the element for the fourth time, and top is equals to size minus 1. Top is equals to size minus 1. So this time top is 2 is equals to size minus, size is 3. 3 minus 1, 2. 2 is equals to 2 is true. Then it will say stack is full. And it is going to return from here. It is going to return, the control is going to return from this without coming to the next steps here. So this is how the push operation generally works. Next we have the pop operation. Now I just want to pop the elements. I just want to remove the element, the topmost element here. So first it will check, is top is equals to minus 1. Okay. No, top is not equal to minus 1. Top is equals to 2 is equals to minus 1 is false. Now printf pop number is stack of top minus minus. Now you are using post decrement. Post decrement. What is stack of top? Stack of 2 is 20. 20 is displayed on the screen and the top is decremented to 1. 20 is okay. 20 is displayed on the screen and the stack means the top value is decremented to 1. Again, if you want to pop, is 1 equal to minus 1 is false. Then it again stack of top minus minus. So stack of what is stack of 1? 15. 15 is displayed and the top is decremented to 0. Okay, post decrement. So we are using all the things which we have learned earlier. I told you many times that in data structures we will be using all the things which we have learned earlier in the C now. Okay, then again, third time if you want to pop, again 0 is equals to minus 1 is false. Again, pop number is stack of top. What is stack of top? What is stack of 0 is 10. 10 is displayed on the screen and 0 minus minus, it will become minus 1. Will become minus 1. And now fourth time if you want to pop the element, minus 1 equals to minus 1 is true, then it will say stack is empty and it is going to return. Got it? So this is how we are going to insert the elements and pop the elements in the stack. Right. Now show function is the same thing, a similar version to this. If top is equals to minus 1, we are saying top stack minus minus. Otherwise, we are assigning I is equals to top, I greater than or equal to 0, I minus minus. So if suppose top is 2, imagine top is 2, then I is equals to top is not equal to minus 1. Simply we say I is equals to 2, 2 greater than or equal to 0, 2 minus minus. First stack of 2 is displayed, 2 minus minus 1, stack of 1 is displayed. Again 1 minus minus, stack of 0 is displayed. Again I minus 1 greater than 0 minus 1 greater than or equal to 0 is false, then it is going to quit. So this is how we can implement. Of course, I have not implemented all the methods which are mentioned in this particular um, presentation. Of course, I have taken this presentation from net. Actually, it's not prepared by me. Or anyhow, whatever it is, see here, we have just implemented the stack. We have created a stack. We have inserted an element. We have removed an element. If you want, you can implement the peak element to just to show the topmost elements. Of course, in our program, we are showing all the elements, and you can go for this isEmpty method also. You can also add every time you can ask what is the size of the stack. These are all extra methods you can implement by yourself using your skills. Okay. So any doubt for anyone?
No, sir.
No, sir.
No, sir.
See, these programs actually looks very easy for you and also very simple when you are just listening. But later on, it will you will get confused. So if you are having any little bit of doubt, also you can ask. Or otherwise, after completion, compulsorily, what you have to do is you have to work on this. Then only you can able to follow. Right. So if you are having any doubt, you can ask. Okay. Now let us continue. Let us continue and we talk more about this stack. So what type of applications generally the stack is having? It is actually used to reverse a word. You can push a given word to the stack letter by letter, then pop the elements from the stack. See, one of the application here is if you want to reverse a word, so what you can do here is you can character by character, you can push them into an array, and then you can pop the elements in the reverse way. So then the string can be reversed. So also the undo mechanism in a text editor. So that's whatever the undo. See in C sorry in your Word, MS Word, you have this undo operation. So whatever the operations which are doing right from beginning to end, you can undo the operations there. So what generally happens here is whatever the operation you are doing, these are actually placed in the stack one after the another. So when you are on to undo, the topmost, the recent operation will be undone. Then the next recent one to the beginning, you can undo all the operations. And ఇప్పుడు మీరు ఇక్కడ MS Word యూస్ చేసినప్పుడు జనరల్ ఏమవుతుందంటే వన్ బై వన్ అండూ చేసుకుంటూ వెళ్ళొచ్చు. అంటే కేవలం జస్ట్ లాస్ట్ ఒక ఆపరేషన్ అయితే కాదు. ఇప్పుడు మీకు ఈ నోట్ ప్యాడ్ అనుకోండి, జస్ట్ ఒక ఆపరేషన్ మాత్రమే నేను అండూ చేయొచ్చు. అంటే ఇక్కడ పెద్ద స్టాక్ ఉపయోగం ఉండదు. కానీ చూడండి అప్లికేషన్ ఎలా వస్తుందండి. ఫర్ సపోజ్ ఎంఎస్ వర్డ్ లో మనం ఏం చేయొచ్చు చూడండి. అంటే అండూ ఆపరేషన్ చేసినప్పుడు ఫస్ట్ ఏమీ లేదు. ఓకే, నౌ వాట్ ఐ హావ్ డన్ ఈస్ I type Kakinada. So this Kakinada is stored in a stack at the bottom. తర్వాత నేను ఏం చేస్తాను, దీని యొక్క సైజ్ ఇంక్రిమెంట్ చేస్తున్నాను. సెకండ్ టైం, థర్డ్ టైం, ఫోర్త్ టైం, ఫిఫ్త్ టైం, సిక్స్త్ టైం. ఓకే, తర్వాత దీని యొక్క ఫాంట్ చేంజ్ చేశాను. దెన్ అగైన్ ఐ హావ్ చేంజ్ ద ఫాంట్. ఇప్పుడు నేను అండూ చేస్తున్నా. అండూ చేసినప్పుడు చూడండి, ప్రీవియస్ ఫాంట్కి మారి, మళ్ళీ ప్రీవియస్ ఫాంట్కి మారి, ఈసారి మళ్ళీ పాత ఫాంట్కి మారి, సైజ్ తగ్గుతుంది. అంటే ఒక్కొక్క ఆపరేషన్, ప్రతి ఆపరేషన్ నేను చేసిన ప్రతి ఆపరేషన్ కూడా అది ఏం చేస్తుందండి, అండూ చేసుకుంటుంది. అలాగే ఇది రీడూలో కూడా ఏం చేస్తుందంటే చూడండి, క్యూ ఆఫ్ ఆపరేషన్స్, నేను చేసిన ఆపరేషన్ వన్ బై వన్ ఇందులో స్టోర్ చేసుకుంటే క్యూ అనమాట. అఫ్ కోర్స్ నెక్స్ట్ చెప్పుకునేది అందులో ఏంటంటే ఫస్ట్ ఏం చేశాను, నెక్స్ట్ ఏం చేశాను, నెక్స్ట్ ఏం చేశాను. సో మనం రీడూ అయినా చేయొచ్చు, అండూ కూడా చేయొచ్చు అండి. సో ఈ రకంగా మనం ఏంటంటే స్టాక్ ని మనం యూజ్ చేసుకోవచ్చు. అలాగే బ్యాక్ ట్రాకింగ్, వెన్ దిస్ ఇస్ అ ప్రాసెస్ వెన్ యూ నీడ్ టు యాక్సెస్ ద మోస్ట్ రీసెంట్ డేటా ఎలిమెంట్ ఇన్ ఎ సిరీస్ ఆఫ్ ఎలిమెంట్స్. సో బ్యాక్ ట్రాక్, సో గోయింగ్ బ్యాక్. అలాగే లాంగ్వేజ్ ప్రాసెస్, మీ యొక్క కంపైలర్స్ లో వాటిలో కూడా ఇది యూస్, ఇట్ కెన్ బి యూస్. Conversion of decimal number into binary is also done by the stacks. So you have a problem called Towers of Hanai problem that also can be solved using the stack there. So Towers of Hanai, one of the very famous problem. You can Google out and you can see what actually the problem is here. Okay, so that is one of the application where the stack can use. And another very interesting thing here is conversion of infix expressions to prefix and postfix expressions. So we have infix expressions where they can be converted into prefix and postfix expressions. So at the end of the session, once I cover all the things, possibly I will discuss one of the application where we convert the infix notations to prefix or postfix notation. And generally ఏంటంటే మనకి evaluation చేసినప్పుడు whenever the computer want to evaluate any mathematical expression, it will first of all convert it into the postfix expression and then it is been evaluated. Okay, so in general an example of that is, suppose what is an infix expression for? So a plus b, sorry, a plus b. So this is an infix notation. Infix notation. Then we have prefix notation, a plus ab. Then we have postfix notation, ab plus. So for converting infix to prefix or postfix, okay, converting an infix notation and infix expression to an prefix or postfix expression, stack is used. How we will learn it later on. Okay, so this is so logic. Another application is quicksort. Of course, we have used quicksort. We have done quicksort earlier using recursion, but you can use stack without recursion. You can use stack and you can perform the quicksort. You can implement the quicksort algorithm. And runtime memory management is also done by this stack. So as I just told you that an expression is a combination of operands and operators. There are that after evaluation results in a single value. Any expression is written, it is a combination of operands and operators. We have a lot of operands and operators. The operands consist of constants and variables also. Okay, an expression is generally an infix expression if the operator is in between the two operands. If an operator, now see here as I just told you, a plus b. If the operator is placed between the two operands, it is called as an infix expression. Okay, then what is a postfix expression? If an operator is followed by the two operands, it is called as an postfix expression, ab plus. And what is a prefix expression? An operator where precedes the two operands, which comes first, which comes in the beginning here, it is called as a prefix expression. Okay, now the evaluation here. So we have an algorithm for this, where we have this infix notation, C, a plus b to the power of c minus d into e minus a by c. So a plus b power c minus d into e minus a by c. So this expression, if you want to convert it into a prefix notation, this is the prefix notation star plus a minus, okay, power symbol b c d e minus e slash ac. So to convert an infix notation to prefix, so the stack is used. Of course, to convert an infix to postfix also, so the stack is used. ABC, okay, power d minus plus EAC slash minus d. So for the conversion, this is what you are going to use a stack, and then you are going to insert the symbols, and then you are going to pop, and you are going to add it to the expression to make it a postfix notation there. Of course, the algorithm is not discussed here, so sometimes, so it will be very hard for you right now instantly to catch up that. So I'll just postpone it to later on, where I will discuss this algorithm, where how to convert an infix to postfix notation. Okay, for sure. So that is about the stack operation. Okay, next we have Q. Okay, Q I will discuss tomorrow in the next class. That is about stack. So any doubt regarding this?
No, sir.
Anybody?
No, sir.
No, sir.
Hello? Hello?
No, sir. No doubts.
No, sir.
Uh,
No, sir.
okay, ma'am. Okay. Fine then. Okay, just you go through this video once again. And I will. Okay, I will catch up with you with you tomorrow. Probably tomorrow. Okay.